This nasty mess is the result of sheep blowflies. Once they could be killed by organophosphate insecticide, but in the 1960s they developed a resistance to it. Scientists from Australia's science agency, CSIRO, were curious as to how it had happened. They discovered that an enzyme in the resistant flies was changing just one amino acid in the insecticide, making it useless.
When the blowfly larvae was sprayed, instead of keeling over and dying, they ate the insecticide and spat out non-toxic products. And we thought, well, if this enzyme can do such a good job inside the fly, why can't it do a good job outside of the fly?
Dr. Robin Russell and her colleagues thought they'd see if this enzyme would do its trick in cleaning up insecticide-contaminated soil. And along the way, they discovered a bacteria that did an even better job.
Bacteria, when they're faced with, if they're sitting in the soil, in a cotton field for instance, and they come in contact with a lot of insecticide, they'll use the insecticide as a food source. So rather than, like an insect does, chew up a little bit that might kill them, these bacteria will eat it for breakfast.
After growing large amounts of the right enzymes, in collaboration with the company Orica, tests were conducted on runoff water from cotton fields, where large amounts of insecticides are used.
In the first instance, what we're going to be trying to do is clean up residues in runoff water. The irrigation has occurred after the pesticides have been applied, so the water that then runs off is contaminated with pesticide, and that's what we'll be trying to clean up in the first instance.
It's hoped that eventually the enzyme can be developed as a powder. Dr. Russell hopes it may even be possible to insert genes which produce the enzyme into trees and bushes. They could then clean up contaminated sites as they grow.
That's something I dream about, why not?